What's up, Eco Nerdlings? In this podcast, we're going to be discussing waste. What is it? What do we do with it? And how do we fix our waste problem? So before we get started, I have some questions that I want you guys to jot down. So take a moment, pause this slide and the next slide, write down the questions, and over the next several podcasts, I want to make sure you answer each of these questions in your notes, and you'll be able to discuss them in class. All right, so let's dig in. So the main core case study for this unit is the Lovell Canal, as well as e-waste. So what happened with the Lovell Canal? There is no away from this situation. So between the years of 1842 and 1953, Hooker Chemical sealed multiple chemical wastes into steel drums and basically dumped them into an old canal excavation site called Love Canal. In 1953, the canal was filled and sold to Niagara Falls High School, or the Niagara Falls School Board, and it was sold to them for a whopping $1. The company inserted a disclaimer denying liability for waste. So basically, like, when you're listening to the radio and they have some type of, wonderful, drug product or something, new prescription drug, and they're like, oh, your life will be so amazing and all of that. And then, at the end, they have the guy reading it at like warp speed, like may cause diarrhea, death, la 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 la. Kind of like what this is, basically denying any type of liability for the waste. By the way, probably should have known a little better when they got all of that sold to them for $1. But anyways, let's continue. In 1957, the Hooker Chemical warned the school not to disturb the site because of the toxic waste that was underneath it. However, they didn't listen, and in 1959, an elementary school, playing fields and homes were actually built on top of it, and this disrupted the clay cap covering the waste. If you remember, clay is kind of a good insulator, a little bit of a filter. So then, let's fast forward for about 2 decades. In 1976, residents started to complain about chemical smells, and people were actually developing chemical burns from the site. So finally, in 1980, President Jimmy Carter declared Love Canal a federal disaster area and it had to be evacuated. So this is a picture of all of the homes and the community that basically was uplifted from their, their regular life because of toxic chemicals. So they had to move this entire community away because of that dump site. It's still in controversy as to how much the chemicals at the Love Canal injured or caused disease to all of the people and the residents that lived there. The Love Canal sparked the creation of the Superfund Law. So one very good thing came out of it. And that law actually forces polluters to take responsibility for the cleanup after they've done whatever they want to do, whether it's mining, excavation, anything like that. So it makes them responsible for the cleanup of the site, and they can't just abandon toxic waste anymore. So wasting resources. In this podcast, we're going to talk a lot about solid waste. Solid waste is any type of unwanted or discarded material that we produce that's not a liquid or a gas. We have 3 main types of solid waste. We have municipal solid waste, which is produced directly from our homes. So that's like, we throw things in our trash can and then we put them in our big green bin and, someone has to wheel it out to the driveway or to, wherever it gets picked up. And, eventually that magic like trash fairy comes, it picks it up, and then it's gone. And we never really think about it again. So that's municipal waste, meaning, basically everyday, waste that we accumulate in our homes. The second type of solid waste that we have is industrial solid waste. This is produced indirectly by industries that supply people with goods and services. So large manufacturing that goes on and all of the wastes that pertain to those. So large companies producing, tons and tons of products. And then the third type of solid waste that we have is hazardous toxic waste. This is the type that threatens human health and the environment because it's toxic. It's chemically active, it can be corrosive, it can be flammable, it can be a carcinogen, meaning that it can cause cancer, tetragen, which means it can cause birth defects, so not good stuff. Make sure you do know the 3 types of solid wastes and at least one example for each. So this is to kind of give you guys an idea of how huge of a problem solid waste has become. This man right here is in Jakarta, Indonesia, and this is actually a river. It doesn't really look like it. It kind of looks like his boat is stranded and, maybe it rained a lot and he's kind of in a little puddle. But this is an actual real river that is just so polluted with all of this solid waste that you can't even see the river anymore. And this guy right here is basically going through all of this waste. I'm sure some of it's toxic, so I know it's not healthy. And he's trying to salvage some stuff that he might be able to sell or get money for to provide for his family. So, of course, we, the United States, produce about a third of the world's solid waste, and we bury more than half of it in landfills. We are also the #1 country, yes, #1, not one of the things to be proud of, in the entire world in solid waste production. So about 98.5% of our waste is industrial solid waste, and the remaining 1.5 is municipal. So about 55% of the United States municipal waste is dumped into landfills. 30% of it is recycled or composted, which is amazing, but if only 30% of 1.5% is recycled or composted, that leaves a lot more. So we really need to focus on the industrial solid waste. We, the municipal waste people, like you and myself, we're starting to do a little bit better with recycling, composting, that type of thing, but the real problem is with the industrial solid waste. And that's something that you guys are going to have to deal with in the future. And then the rest of the municipal waste, about 15%, is burned in incinerators. So basically we burn it. All of those wonderful toxic fumes are released up into the atmosphere. So I wanted to give you guys an idea of some of the toxic things that you actually have in your house that, are just kind of common everyday items that you may not even think about, but they're not very good for the environment. So cleaning supplies such as disinfectants, so your Lysol sprays, bleaches, little scrubbing bubbles that you spray in your shower and your toilet, Drano, so if you get a clog, you pour the Drano down, Windex that we use to clean our windows, spot removers, septic tank cleaners, lots of paint products, so any type of paint supply, paints, thinners, lacquer, solvents, strippers, art paints and inks, all of those are bad for the environment. Some of the general things, dry cell batteries that contain cadmium and mercury, different types of glues and cements. And then if you are a gardener and you're using pesticides, weed killers, ant and rodent killers, or flea powders, that's all contributing to toxic waste as well. Automotively speaking, obviously we have big problems with gasoline, used motor oil, used antifreeze, battery acid leakage, and brake and transmission fluid. So these are all common items that we all know about, but they're becoming an increasing problem. So again, the United States is unfortunately the leader in solid waste, and that's a huge problem. So, we talked a little bit about what we're throwing away, but what are we going to do about it? We're also the leader in trash production by weight per person. So meaning that per person we produce more trash by weight than any other country in the world. However, like I said earlier, recycling is helping, but we need to bump that recycling more into the industrial world than just the municipal type of trash. So this graph right here is just kind of showing you, right here we have per capita generation in kilograms per person per day of trash. So we basically had exponential growth till I want to say late 90s, early 2000. Then we kind of realized what we were doing, we leveled off, and we're even seeing a slight decrease now. The blue line right here is representing the total municipal solid waste in millions of tons per year. And again, kind of same trend, we had pretty much exponential growth, and then eventually we started leveling off again, late 90s, early 2000s. So one of the other core case studies in this unit is e-waste or electronic waste. So think about how many, plastic and metal parts you've got rid of, wires, old keyboards, old computer mice, old video game cartridges, old video games. We have, all of these things because every year they come out with something newer, bigger, better, or smaller and better. You know, cell phones, computers, laptops, iPads, iPods, you know, MP3 players, and all of these, you know, it's basically like, what's the next best thing? What do we do with it? We kind of chuck it in the trash. So e-waste consists, again, you know, toxic hazardous waste, PVC, and a lot of the different types of materials that they use to build all of the electronics actually house hazardous waste, such as lead, mercury, and cadmium. And again, we're in the top. The United States produces more than half of the world's e-waste, and unfortunately, we only recycle about 10% of that. So one of the places that we discard all of our solid trash is landfill. And by definition, landfills are basically a hole where solid waste is placed. It's compacted and then covered with soil. The reason we cover it with soil is because we want to reduce the smell and the number of rats. Yes, rats. Associated with the solid waste, and it lessens the danger of fire as well as decreases the odor. Because if you have ever been anywhere near a landfill, even though they've covered it with, you know, dirt, it smells. So current criteria for landfills, landfills cannot pollute the surface or the groundwater. They have to be compacted with clay and plastic sheets that are at the bottom, and this helps to prevent liquid waste from seeping into the groundwater. And they also have to have a double system put into place, so meaning plastic, clay, plastic, clay. And the system is there to collect the leachate, which is basically liquid that seeps through all of the solid waste. Because even though it's solid waste, think about, you know, if it rains or something, all of that is kind of going to settle and start seeping through and create this nasty, gross, liquidy, sludgy stuff. So we're going to talk about some of the things that are commonplace and what we have to do with them. So are they able to go in a landfill or are they not? So oil, not allowed in landfills. Has to go to automotive or environmental company for recycling. Tires can actually be placed in landfills as long as they're quartered, and they also have to be shredded. Antifreeze, not allowed in landfills. Again, has to be sent to automotive environmental company for recycling. Same thing for air-conditioned coolants. Again, not allowed in landfills. Lead acid from car batteries. Again, not allowed in landfills. One of the things that we can do to help out a little bit, and this is something that I basically mentioned a little bit earlier in this podcast, are creating composts. So composts are a sweet smelling, which I kind of disagree with the sweet smelling because most of the composts I've smelled smell like something else. They're typically dark brown because they're very rich in nutrients. They're a humus-like material that's rich in organic material as well as soil nutrients. So this is a picture of a compost drum. So basically, we use bacteria, and we can convert all of our kitchen waste into compost that we can use in our gardens to help grow fruits and vegetables and plants. So if you want to start your own garden, this might actually be a good idea. Basically, anything that's degradable can go into compost. So leftover fruit peelings, eggshells, you know, any type of food product can pretty much go in there. You can compost some types of paper plates and things like that. But mostly we're going to be talking about, you know, food waste that's going to be composted, as well as, you know, throwing in some grass clippings and some leaves, and then you'll get this really rich compost that you can actually use as fertilizer. So what are some of the benefits of composting? Well, you can help aerate the soil. It's going to improve the soil's ability to retain water and nutrients if we're adding this to it. We can help prevent erosion by adding this. And it also prevents nutrients from being dumped in landfills or wasted because we can use all of those nutrients to help fertilize plants. So what exactly do you need to create your own compost? Well, 6 to 12 inches of grass, leaves, other plant materials. You're going to need some shade. You might want garden fertilizer or manure. You can use, you know, different types of soil, water. Obviously, you're going to need air. So those are all things you can do to create your own compost. So again, one of the other things we spoke about was recycling. Basically, using something old and turning it into something new. So we're going to recycle it. Again, converting something old into something new that we're going to use again. So we have tons of organic matter, and organic solid waste actually comprises over half of the solid waste. And it includes all kinds of yard debris. So, when you rake up your leaves or you prune your trees, things like that. Lots of wood materials, whenever we have demolitions that come in and, take down buildings or houses, old fences, biosolids, food, manure. If you don't know what manure is, it's basically poop. Agricultural residues, land clearing debris, as well as used paper and mixed municipal organic wastes. Organic materials have been dumped in landfills and they're burned as well. So these are all things that we can actually use because these are the types of things that can be composted at a large scale. So the general purpose of recycling or composting is that it's going to save land, it's going to reduce the amount of solid waste that we produce, it's going to help reduce energy consumption as well as pollution. So for example, recycling just one aluminum can actually saves the energy of about 6 ounces of gasoline. So another example is that gold, lead, nickel, steel, copper, silver, zinc, and aluminum are all recyclable. Yes, we can actually recycle all of those metals. However, recycling is not without its problems. Nothing is perfect. So recycling does have some environmental costs. It actually does use energy and it does generate pollution. So for example, whenever we're de-inking paper to recycle it into another form of paper or something else, it requires energy and it actually does produce a toxic sludge that contains all of the heavy metals from the inks. But the benefits pretty much far outweigh the costs. It's going to help us to conserve our natural resources. It has a positive effect on our economy by generating jobs and revenues. So another example, the Sunday edition of the New York Times consumes 62,000 trees. And currently, only about 20% of all paper in North America is recycled. Well, I hope you learned a little bit about solid waste, beginnings of composting and recycling. If you'd like to rewatch this video or any other one from AP Environmental Science, you can visit my website at www.nerdlingscience.com. Well, this is the Queen Nerdling signing off for now. Stay nerdy till next time.